Let's have a look at HTTP, the protocol and architecture that drives the World Wide Web. We'll have a closer look a bit about the historic background, and then we dive into how does the communication work in this World Wide Web. This course is not about web pages, programming, HTML, JavaScript, etc., but it's about the communication part. So about HTTP and some new developments, WebSockets, WebRTC, the real-time communication part. We'll have a look into cookies, so how to store state in this system, talk about proxies, show you a bit about how to scale web server architectures, and then finally we'll combine DNS from a former chapter with HTTP. What does this mean? So first of all, some very basic concepts. You all know a browser, that's nothing new. So you know that with the help of the browser, you can start requesting resources, remote resources. For example, a HTML file. So you request it and the web server replies to your queries. So the query is, please give me this and that content, and the response will then contain an HTML file. So that's the simplest example. And the protocol we use for this is HTTP. So it's very simple. You have your browser somewhere, and the browser sends over a request. And how does it look like? Well, that's exactly what HTTP is for. HTTP will tell how the syntax is, but also the semantics of the request, but then also of the response that follows. And then the browser can go through the response, continues, etc., etc. So then the response typically contains, again, references to other servers, to other resources like images, like audio, like video, etc. And how do you reference? These are our well-known URLs, Uniform Resource Locators. You all know them. You actually grew up with this. So the description, again, of the pages, that's done with HTML, HTML5 right now, and HTML5 plus cascading style sheets, plus JavaScript for having some dynamic pages. That's not the topic of this course. HTML, etc., standardized by the World Wide Web Consortium. So we will have a close look into how we obtain the other docs and what we do, how this is a name. So we know already what to do with names. We know how to get an address out of this. Remember, DNS. But then, what do we do then? So that's the idea. And pointing to other docs, which then again point to other docs, that's our World Wide Web. So that's the application on top of the classical internet. Many standards related to this. You can imagine it all started longer time ago. So back 1996 with the very first standard, HTTP version 1.0, 3 years later 1.1, which was for a long time the dominant version of HTTP. There are also standards for URLs and the a bit more flexible concept of URIs. I bet most of you know URLs, Uniform Resource Locators, telling you where a resource is. But why do I have to tell the system where something is? So maybe I just want to describe what I want to see. I want to read the news, whatever. And this is the basic idea behind Uniform Resource Identifier. So we just identify a resource no matter where it is. So URLs are kind of already tell you the location, so you have to know it. But basically something like a search engine, Google search, whatever, translates you, well, I want to read the news, and then will give you a URL for the news. There are also some other paradigms, information-centric networking. I will come back to ICNs later on. So it's kind of, well, we don't have to know the location, we only know the content. So the web, that was this kind of, well, huge boom from the mid-90s, all the dot-coms, all the bubbles and all the problems with this. So at around the year 2000, we had some newer developments then. It took a while. We will see what the problems with the classical HTTP 1.1 is and why we need something a bit more complicated. HTTP, the version 2, published in 2015. So you see, okay, that's some time from 99, 16 years later. And right now, about 1/3 of all websites use HTTP in this version 2. But this is declining because, well, what's new? It's HTTP version 3, no big surprise, which is basically HTTP 2, but now replacing the classical TCP protocol, layer 4 protocol, using new protocol QUIC. We will have a more detailed look into QUIC in a later chapter. And right now, almost 1/3 of all websites already use this HTTP 3. I will show you where are the benefits and why do we see increasing use of HTTP 3. So today we have the World Wide Web Consortium, W3C, that organizes almost everything around the web. Plus we have the IETF standards, as you see in here. W3C has full-time staff and everything works together. And this is also where one of the inventors of the web, Berners-Lee, takes an important role. So today you see a whole family of IETF standards harmonized with this W3C developments. RFCs for the semantics, so what does it mean when HTTP says something about caches, and that's exactly where we'll have a closer look into, that's the RFCs for the transfer of the data. HTTP, the old version 1.1, the newer version 2, and the newest one, version 3. And then additionally, you have all these more HTML, etc. related mechanisms, JavaScript and cascading style sheets, etc. WebRTC. This is where we have the World Wide Web Consortium. Okay, so many standards defining what's going on there, and we'll have a close look into some of them. Before we start, some background. So some historic background. Is this all brand new with the World Wide Web? Well, not really. It's interesting to see that the history really goes back to 1945, when Vannevar Bush sketched something like a hypertext concept. So hypertext concept, memory extender, memex, kind of a desk. It was a rough sketch, a desk with something like touch screens and monitors and a scanner surface and some storage where you can access text and graphics, and this is indexed with a kind of associative memory, so that something already, well, memorizes more this in the way our brain does it, not like classical computer networks. Well, that's history. And in the early 60s, we had Doug Engelbart and working on hypertext models. So running on a computer, the idea of hypertext. And a year later, Ted Nelson coined this term hypertext. Hypertext, that means, well, okay, we have links in a text linking to other documents. So, but still, I mean, we didn't have the internet, we didn't have computers on all desktops, etc. So the idea was there already in the 60s. But then we had the internet itself, and then Berners-Lee came up with the basic idea of the World Wide Web, which then became famous in the mid-90s. And the key idea of Berners-Lee was actually connecting this hypertext idea with TCP and DNS. And this is why we need the internet. So there we have TCP/IP, the protocol family, and DNS. So the World Wide Web basically today gives the access to interlinked documents, and the documents themselves are distributed over many thousands of computers in the internet. So the key motivation of Berners-Lee was, well, how to organize a huge amount of documents distributed over several computers. At CERN, so you have this huge accelerator and you have masses of data and documents, and the idea was first it was all text-based, or text-based is not really for the masses, but already then, well, we used the internet as the data delivery service and pure text, and then it was further developed, and it started then with the first graphical user interfaces, Mosaic, Netscape, Internet Explorer. Mosaic was a quite simple thing, a gray background and black text, but the links already, they were blue, and this is where the color blue comes from. So it's far from what we have now, but still, that's the key idea. So the idea to exchange data, but also figures with all the different project partners. So today, we still see similarities on the right-hand side, standard browser of today, more colorful, but we still have links. They don't have to be blue anymore, and the background doesn't have to be gray anymore. It's way more dynamic, and it's way more geared towards mobile devices, so it adapts automatically the look and feel depending on the screen size, etc. So that's what we know from today. So we started with very simple, very static web pages, and this is also reflected in the protocols, as we will see in a moment. And today, everything is way more dynamic and colorful. So, simple, static pages. Well, some years ago, everything became way more interactive. So we have interactive content. So this is not static anymore. You have things like tweets suddenly. Oh, that is way more dynamic. New content, well, is visible, should be pushed onto the server. But as we will see, the browsers and the protocols and the architectures made for the classical static content cannot handle pushing something. So interactive content, that's new. And then today, we do not have only the consumers of static content, or here more active consumers, prosumers. We have real-time content. Well, now the focus is on real-time. We have videos, interactive videos, and that's a problem for the classical architecture. So the question is, how do we bring content to end users? We will see it's not the browser requesting content and then you get a response. We need something else. Maybe we have communication between peers, between two browsers. How does this work? So we have to think about the communication protocols and about the different properties. Do the properties fit to the applications? Static content, content that has to be more pushed, and now more this peer-to-peer real-time content. So depending on the different applications, maybe we need different types of protocols. We start here. Here, the first scenario, we have huge masses of content, a huge user base. So thousands of users accessing web pages. That's different from a user looking at content, maybe hundreds of users, but maybe also thousands, tens of thousands. Well, looking at changing dynamic content. Here we have these tweets or whatever, X's, I don't know how you call them, as we don't have Twitter anymore. So that's something different. And then the third scenario is where we have a maybe peer-to-peer, browser-to-browser video conferencing system where we need very low latency. So this is more real-time. So for the first scenario, well, that's classical client-server. We know this from other scenarios. You learned this from DNS, for example. You have a request and then you get an answer. So client-server model. That's this pull paradigm. I need a resource. So now I click here on this event link and then I need the resource, please now. But you as a user, you're active, you're clicking on something. You click on the picture here and then you get a content. But what? Scenario 2, you don't do anything. And now do you really want to click every 10 seconds to refresh the content of something? No, we need something that is called the push paradigm. So we push new content on a page. That doesn't work with a classical client-server model, with a pull paradigm. And in the third scenario, We have to support direct communication between end users. So client-server doesn't work here. Pushed paradigm also doesn't fit. What to do there? But this is all available today. These are all different types of web applications, and the browsers support them. The question is, how? Do the classical protocols fit, or what do we need here? So that was the introduction, but still some questions. Please go and check the world of standards. Just check out who's doing what. What is the role of the IETF? What is the role of the W3C? Where do we specify the transport protocols, the semantics of those protocols? Where do we specify the content? And you can have a closer look into the content. For example, go into something that's called either a developer mode or something similar in your browser, enable developer mode, and immediately you will see what's behind a web page. How does the HTML code look like, the CSS code, the JavaScript, etc. You will learn a lot. Then look again at the different usage scenarios. So which communication paradigm fits best, or at least better, compared to other communication paradigms? So you browse through a newspaper, you browse through your favorite website, or you follow live blogging of some events. There's something going on, sports event or product presentation. How does it look like? What do you need? Or if you think multi-party video conferencing systems, so can they work with client server? What do you need there?